Alright, this is the last section for rational expressions, equations, and now we're going to talk about functions. So a couple things that we're going to do here is we're going to talk about evaluating functions, and we're also going to talk about domain. So let's go ahead and start. First thing that we're going to do is talk about evaluating rational functions. This is nothing new. Remember that when evaluating rational functions, our first step is replace the variable with the number inside the parentheses. We're going to simplify using order of operations, and then we'll be done. Okay, so let's look at some examples here. Our first example is f of x equals x plus 4 over x squared minus 3x minus 10. So the first thing that we're going to do is we are going to go ahead and replace x, our variable x, all over the function with 2. So if we do this, we're going to get 2 plus 4 over 2 squared minus 3 times 2 minus 10. All right, if we go ahead and simplify now, we get 2 plus 4 is 6. On the bottom, we get 4 minus 6 minus 10. If we simplify the denominator further, we get 6 over negative 12, which simplifies down to negative 1/2. So f of 2 equals negative 1/2. Similarly, if we do f of 1, we're going to plug in, so we get 1 plus 4 over 1 squared minus 3 times 1 minus 10. If we simplify the numerator, we get 1 plus 4 is 5. Denominator will become 1 minus 3 minus 10. If we simplify the denominator further, we get 5 over negative 11. The fraction doesn't simplify, so we get f of 1 equals negative 5 over 11. All right, let's try another example. Let's look at another function. If we look at h of t, we have t squared plus 5t over 2t plus 5. So h of 1, if we plug in 1, we get 1 squared plus 5 times 1 over 2 times 1 plus 5. All right, if we do our exponents and our multiplications, we get 1 squared is 1, 5 times 1 is 5, and on the bottom we get 2 times 1 is 2, plus 5. This simplifies down to 6 over 7. So h of 1 equals 6 over 7. All right, let's try h of 5. If we plug in 5 to our function, we get 5 squared plus 5 times 5 over 2 times 5 plus 5. Simplifying it, we get 25 plus 25 over 10 plus 5. If we add, we get 50 over 15. I can divide both of these numbers by 5, which gives us 10 over 3. And that takes care of evaluating functions. Okay, what else can we do with functions? We want to talk about the domain of rational functions. So we briefly mentioned this. We didn't call it domain, but we briefly mentioned the fact that with rational functions, the denominator cannot be equal to 0. And that is our domain restrictions. So in order to determine the domain of all real numbers, we're going to set the denominator equal to 0 and solve using either linear or quadratic techniques. And our domain is equal to all real numbers except the numbers that we came up with when we solved. All right, so let's look at the same examples that we had before, but we're going to talk about the domain. So remember that domain, we're going to talk only about the denominator. Numerator can do whatever it wants. We care about the denominator. So I'm going to start by setting my denominator for f of x, the bottom. I'm going to set this equal to 0. This is a quadratic equation, and so I'm going to solve using factoring. So x squared breaks down to x and x. Things that multiply to 10 and combine to 3 is going to be 5 and 2. We have different signs, and I want my larger number to be negative. So we get x minus 5 and x plus 2. All right, if we go ahead and set each one of these equal to 0, we can solve the first one by adding 5 to both sides. The second one, we can subtract 2 from both sides. And now we want to go ahead and interpret this. So our domain is all real numbers except x equals 5 and 2. Another way that you can write this is you can use the not equal sign. This says x is not equal to 5 or negative 2. There is a third method for, I'm not going to cover how to write the domain in terms of interval notation. It gets rather complex looking. And so if you do see it and you want me to explain it to you, please feel free to contact me. Okay, let's look at one more. We have h of t equals t squared plus 5 over 2t plus 5. Again, the first thing I'm going to do is I just care about my denominator. So I'm going to set my bottom equal to 0 and solve. We can subtract 5 from both sides. And we can divide by 2. So what we have is t equals negative 5 halves. But remember, this is domain. And so our domain is all real numbers except t equals negative 5 over 2. Or if you want the short version of this, we just say t is not equal to negative 5 over 2. All right, so there are some examples of domain. Now, before we've talked about range, and when we talk about rational functions, this is one of the most complex ones in order to determine range. This is not something that we're going to look at in this class. You will probably see it in either the next class or the one after that. But for now, we will just talk about domain, as that one is fairly easy to compute. Okay, so let's do some more with our restrictions on the domain, and let's talk about simplifying functions. So simplifying functions, basically what we're going to do is we're going to add and subtract this, just like we did when we talked about adding and subtracting functions. And what we're going to do is just ignore the left side of our function. So if we look at f of x, we have 2x over x squared minus 4 plus 5 over 2 minus x minus 1 over 2 minus x. The first thing that I want to do is I want to rewrite this in descending order, and I'm going to move my negatives in front. So what is that going to look like? The first one will stay the same. I'm going to factor out a negative, and I'm going to write in descending order. So we get 5 over minus x minus 2 minus 1 over negative x minus 2. I'm also going to go ahead and move those negatives to the front and change the signs of these terms. So instead of plus 5, I'm going to make this minus 5 over x minus 2. Instead of minus 1, I'm going to make this plus 1 over x minus 2. Okay, we need to go ahead and factor the first one. This is going to be x minus 2, x plus 2. And so my LCD is going to be x minus 2, x plus 2. All right, so the first one, we don't need to do anything to that. This is just going to stay 2x over x minus 2, x plus 2. The second one, I need to multiply by x plus 2. So I get 5 times x plus 2 over x minus 2, x plus 2. My last one, same thing. I want to multiply by x plus 2. And my denominator is x minus 2, x plus 2. I'm going to go ahead and distribute. Now I'm going to do something kind of different here. This minus sign, I'm going to change it to a plus and put my negative up with the 5, so that we remember to distribute the negative. So what do we get? I'm also going to combine in the same step. First one stays the same. Second one, we get minus 5x minus 10 plus 1 times x plus 2 is just x plus 2 all over x minus 2, x plus 2. Okay, if we go ahead and simplify, I can combine my x terms. We have 2x minus 5x plus x, and when I do that, I get negative 2x negative 10 and 2, if we combine our constants, we get minus 8. over x minus 2, x plus 2. The numerator does, we could factor out a negative 2, but it's not going to simplify any further, and so we are done here. Now, we do want our domain restrictions, so what is our domain? If we set our denominator equal to 0, I'm going to set each factor equal to 0. We get x equals 2 and x equals minus 2. So my domain restrictions, x is not equal to 2 or negative 2. And we're done. Okay, let's try one more, because I know that these ones are going to be a little bit more complicated. Let's look at B. B, we have g of x equals 2 plus x over x minus 3 minus 18 over x squared minus 9. So the first thing that I want to do is I want to factor x squared minus 9. This is difference of squares, so this is going to be x minus 3, x plus 3. So my LCD is x minus 3, x plus 3. Okay, so now let's go ahead and rewrite everything with this denominator. We get 2 over 1. I'm going to multiply by x minus 3, x plus 3 to the top and bottom, plus, second one, I want to multiply by x plus 3 to the top and bottom, and the last term can stay the same. All right, if we go ahead and FOIL, if we go ahead and multiply and combine the x minus 3, x plus 3, remember, don't reinvent the wheel, that's equal to x squared minus 9. And I'm going to go ahead and distribute further. So we get 2x squared minus 18 plus x squared plus 3x minus 18, all of that over x minus 3, x plus 3. Okay, we finished simplifying, so we get 3x squared plus 3x minus 36 over x minus 3, x plus 3. Okay, I can factor now. In the top, we can factor out a 3. We get 3 times x squared plus x minus 12 over x minus 3, x plus 3. I can also factor further in the numerator. If we factor further, we get 3 times x plus 4, x minus 3, all over x minus 3, x plus 3. I can cancel common factors. We do have an x minus 3 in the top and the bottom, so I'm going to cancel those. And what are we left with? we are left with 3 times x plus 4 over x plus 3. Now, our domain restrictions, let's talk about the domain restrictions. Do I look at my finished function, or do I look at the original function? And the answer is we do need to go back to the original function. So when we look at this, what we're looking at is none of these denominators can be 0. So what I'm going to do is I'm going to work with my LCD. This is what I want to know is not equal to 0. So if we go ahead and work on our LCD, I'm going to set my LCD equal to 0. I'm going to set each factor equal to 0. And solve each one of these little equations. So my restrictions on, we get x equals 3, and we get x equals negative 3. And so my restrictions on the domain is x is not equal to 3 or negative 3. Okay, so there are some simplify the functions. Last thing that we want to look at is we want to talk about solving rational functions given the y value. Okay, so if we look at A, it says given f of x equals x minus 1 over x plus 1, find all values of A for which f of A equals 3/5. We looked at this when we talked about the polynomial functions. We're going to do kind of the same thing here. So what we want to do is I want to replace x. Let's look at what we're given here. I'm replacing x with A, and I want to set the whole thing equal to 3/5. So this is what it's going to look like. I'm going to get 3/5 equals, remember we're replacing all of our x's with a's. We get a minus 5 over a plus 1. Okay, this is a proportion. So since we do have fraction equals fraction, I can go ahead and cross multiply. So if we cross multiply, we get 5 times a minus 5 equals 3 times a plus 1. I can go ahead and distribute, and we get 5a minus 25 equals 3a plus 3. I want to move all of my variables to one side. I'm going to move them to the left. I get 2a minus 25 equals 3. Since all of my variables are on the left, I'm going to move all of my constants to the right. I get 2a equals 28. And finally, I want to divide by 2. So we get a equals 28. No. (28 over 2) simplifies down to 14. And we're done. Okay, last example, and then I'm going to have to take a break because apparently I'm losing it. Last one, given g of x equals 6 over x minus 6 over 2x, we want to go ahead and find all values of a for which g of a equals 5. So same thing again. Note that we are replacing our x. It's not g of x, it's g of a. So I'm going to replace all of my x's with a's, and I'm going to set the whole thing equal to 5. So we get 5 equals 6 over, remember x is a, minus 6 over 2a. We want a least common denominator, and my LCD for this is going to be 2a. If we go ahead and multiply, we have 5 over 1, so I'm going to multiply by 2a to the top and the bottom. 6 over a, I'm missing the 2, so I'm going to multiply by 2. And the last one can stay the same. All right, if we go ahead and multiply this out, we get 10a over 2a equals 12 over 2a minus 6 over 2a. All of my denominators are the same. They cancel. So we have 10a equals 12 minus 6, or that's just equal to 6. I can divide by 10. And if we divide by 10, we get a equals 6 over 10. This does simplify further. We can divide by 2. I get a equals 3 over 5. And so there is your summary of rational functions. That finishes this module. The next module we will be looking at is radicals, and I will see you again shortly.